So this quiz, this video is about the quiz that's on the kinds of probability and the law of large numbers. So there's really two parts to it. There's an A and a B. If you remember what it's about. If you don't, no big deal. All right, so what do we got next here? Can I switch slides? Maybe. All right. So there are two kinds of probability. The first question on the quiz asked you about basically like which kinds of probability it was, or it asked you a question about give me the experimental probability or give me a theoretical. The experimental probability is the probability that something actually occurred. So that's why it has experiment at the beginning. It's based on experiment or like real life. So it's like what actually happened. That's the way I think about it. So somebody else have a different way to think about it? What actually happened? Does the word experiment help you? Yeah.
Experimental, like the difference between experimental and theoretical. Experimental is like based on like actually doing the experiment.
Yeah.
And theoretical is based on or tree diagrams and such.
I love that way of saying it. Yeah. So theoretical probability, like it would be based on like a tree diagram or an area diagram. It's like what should happen. You know, what should happen when I flip a coin? Half the time you should get heads. Half the time you should get tails. That's not actually what happens necessarily. It could, but there's a difference between what actually happens and what should happen. So is that okay? All right, and I'll go over an example problem here at the end. I didn't put a slide in for it, but all right. So the law of large numbers, the idea, I know this is too small for you to read it from back there in the classroom, but the law of large numbers, it's this idea of this red line here, this red curve that's like going up and down and up and down. This graph that I pulled off Wikipedia is an average dice value against the number of rolls. So when I rolled it like 5 times, the average is like 2.9. So we're talking about like 1 through 6, like what happened, I wrote it down and then I averaged it out. Now, what actually happens in the experiment is like 2.9 after I rolled it 5 times. But then I roll it like, I don't know, what does it say here, up to like 100 times. It looks like it's at like 3.3 or something like that. There's this light green line here, and what happens is this kind of skips around and goes a little bit above, but towards the end here, it's almost exactly on the green line. That green line is 3.5. What's special about 3.5 is for 6 numbers, 1, 2, 3, 4, 5, 6, they average out for 3.5. So as you roll a die more and more and more times, it should average out to 3.5 about. And that's what this shows. The experimental, the red, you know, kind of skirts around a lot, but then over here, you can't tell the difference. It's like on top of it. That's the law of large numbers. If you do something a ton of times, the experimental probability should pretty much match the theoretical. They should be the same if you do it a ton of times. If you do it one time, no, of course not. If you do it one time, you might get a 6, and then the average is 6 because there's only one of them. But the more times you do something, the more it happens. That might be a confusing example, but this one's a little bit simpler. This graph is flipping a coin 100 times. When I flipped it 1 time, it's up here at 1. So what's that? This must be the percentage of time getting heads. So the first flip was a heads. So experimental probability of getting heads, 100% after 1 time. But in the next one, what happened? It looked like it dipped down. So after a few, then there were fewer heads. And it kind of skips around, but what happens is it kind of evens off here. This gets less and less crazy, less and less up and down. What is the end of this headed towards here?
The average.
And what is the average for flipping a coin and getting heads?
Half.
What should it be? Half, yeah, 0.5. The theoretical probability of getting heads is half. That's what this should approach. At the beginning, it's kind of all over the place, but it gets there. After a whole bunch, we're talking about like close to 100 times. So that's the law of large numbers. That the more and more times you do something, it should match the theoreticals. All right, so that's kind of the background, but what we really need to do are some practice problems. So I'm just going to say them out loud for the people on the video, but I'll write them up here on the board. Actually, I think I can do the same for them. See if I can make this happen. Yeah, that's pretty good. Okay, so let's say that I roll a die. So we're talking like the standard 1 through 6. So there's 6 sides, 1, 2, 3, 4, 5, and 6. And let's say that I get a 4. Like I get the number 4. Let's say I roll it out of 10 times. A 4 came up just once. So I know that might not be super clear the way I've written it because I haven't written out all the words, but I rolled a die 10 times and I got a 4 just once. So I don't know if that's surprising or not. I guess maybe it should happen a little bit more. So if I said, what is the theoretical probability, I'm going to abbreviate that, of rolling a 4? What is it?
4 out of 10.
Would it be 10 out of 60? 1 out of 60. Would it be 10 out of 60?
Oh, it's 6.
Why 60? So right here, this question is basically asking you, you have to know what the difference is between theoretical and experimental, because those are the two possible questions there. You got to know which one is which and which one is the answer here. I think there are two good answers. There's the 1 out of 10 option, because 1 out of 10 times a 4 came up. And then I think the other good option is 1/6, which actually somebody said 10 out of 60, which is the same thing. These are the two good answers. This one is what happened. 1/10 is what happened. 1/6 is what should happen. Like 1 out of every 6 times 4 should pop up. Do you see where I got those two numbers? Now, but only one of them is right for this problem. Which one is the theoretical? Yeah, 1/6 is the theoretical. That's what should happen. Even though I gave you lots of information about the problem, then I asked about the theoretical. And so, I mean, I wasn't trying to throw you off, but you do have to know the difference between them. If I had asked for the experimental, then you would have said 1/10. But since we asked for theoretical, you say 1/6. Sound okay? All right. Now I would say, let's pretend that I rolled 50 more times. So what would you expect to happen? How many times would you expect a 4 to come up?
5, 50.
I think there are two good answers for this one. I think you can say, okay, in the in the next 50 times, I think one good answer would be that it came up 5 times. Because if it happened 1 out of every 10 times, then in 50 it should be 5. So that's, I think, a good answer. But there is another good answer. The other good answer is, well, in the next 50 times, I would expect it to come up about 1/6 of the time. Because that's the other kind of probability. So 1/6 of 50, ooh, I don't think that comes out evenly. Like it's not a whole number, so I wouldn't say that. But 50 divided by 6, maybe about 8 times, something like that. I'm kind of rounding off, being approximate there. But those are the two good answers. One of them is that it will come up 5 times, because 1 out of every 10 times that came up. So, Ibrahim, you texting your friends about how exciting this is? Okay. Snapchatting your friends about how exciting this is?
Yeah.
Mm.
Michelle wants to know.
Where's the microphone?
On the computer. That's why sometimes the video isn't like that great, because I'll like walk over here and be like, oh crap, I mean the theoretical. So that part's gonna be really loud since I walked over there. What does Michelle want to know?
What quiz this is?
Oh yeah. Really glad you guys talk about this stuff outside of class.
Yeah.
I'm surprised, honestly.
Yeah.
I didn't do that when I was outside of school, but I'm glad that you guys are better than I am. Okay, so anyway, 5 is based on this, and 8 is based on this. So which one do you want to use to predict the future? Yeah, 8, exactly, yep. So 8, I should have circled the other one here so they can see it. I circled the wrong one. So theoretical probability is 1/6. You want to predict the future using the theoretical probability. Even though what happened in the past is a 4 only came up 1 out of every 10 times, the law of large numbers says that in the long run, you should still base it on what should happen. If I'm going to flip a coin 100 times, I don't care that heads came up 3 times in a row. You don't think that 100 times in a row, heads is going to continue to come up. You don't want to think that. Gamblers think that a lot, that they're like, do something. Like, oh, I've lost 5 times in a row, I'm going to win this time. No, that has nothing to do with it. Past experience has nothing to do with the future, with independent events like flipping a coin or gambling with money. So don't think that anything is special or that a die or a coin has any memory. All right. Should I say something more? Is this clear enough for this video? It's certainly going to be long enough because we talked about Michelle for a while.
Yeah,
Good enough?
She's famous. She's YouTube famous.
10 minutes.